right, you guys, lesson 20, simplification of radicals and lines parallel to a given line. Right, so go ahead and write down this radical. 4 square root of 40 minus 3 square root of 140. So the only way you can add and subtract radicals is if they're the same radical, and then you just add or subtract the numbers in front, okay? But you have to have the same number under the house. So we definitely can't subtract these just to start with, but what we can look to do is simplify like you guys do most of the time when we've done these, okay? So 40, if you just kind of make a little factor tree, that's what I like to do. 40 is 4 times 10, right? And I'm looking for perfect square numbers that we can factor out of 40. So what's the square root of 4? 2. So the 2 is going to come out front because we took the square root of 4. And that 2 always multiplies to anything that is outside of the radical already, okay? So I'm going to get 8, and the square root of 10 is left inside. Okay, 10 does not simplify any further because it's 5 times 2. There's no perfect square numbers inside of 10. All right, now I have 140. Well, let's just start with 14 times 10. Neither of those are perfect square numbers, but let's go again here. I have 7 times 2 for 14, and I have 5 times 2 for 10. So if you do factor all the way down to prime numbers, that's another way you can do this. I have 2 times 2. What is 2 times 2? It's 4. So what's the square root of 4? 2. So any dates leave the house as 1. Okay, I have 2 of those. We have a date. They leave together, and they leave as 1. Okay, and now they multiply here. So now I'm running out of room, minus 6. Squeeze that in. And inside my house, these guys that don't have dates, they stay inside. 7 times 5, 35. All right, so does this simplify any further? No, it does not, because 35 and 10 are not the same number. Otherwise, we could subtract if they had the same radical. So let's try a multiplication one. So write this one down. I have 3 square roots of 2, and then parentheses 3 square roots of 2 minus the square root of 8. If you wanted to simplify that square root of 8 first, you could, but I'm going to first multiply, then simplify, all right? But it works both ways. But I'm going to go ahead and multiply. So we're really distributing this to this, and then the outside to the second term. All right, when you multiply these, you're always going to multiply the outsides with the outsides and the insides with the insides, okay? So on the outside, I have 3 times 3. That gives me 9. And on the inside, we have 2 times 2. That gives me 4. Okay, finish distributing, so I have a minus sign. What number's in front of this 8, the square root of 8, that we don't really see? A 1. Okay, so now I'm multiplying this outside to this one right here. So the outside numbers together, 3 times 1. And the inside numbers together, 2 times 8 is 16. Oh, this is going to simplify nicely. All right, so what's the square root of 4? 2, and that comes out front, and there's no more radical anymore, so I have 18 because it's a perfect square number. What's the square root of 16? 4, that comes out front and multiplies. And then I have 18 minus 12 is 6. All right, this one's just all multiplication. So write that down. 3 square roots of 2 times 4 square roots of 12 times 2 square roots of 3. So raise your hand if you know which numbers multiply together. Kaden? Okay, all the outsides multiply together. So what's 3 times 4 times 2? 24. Okay, square root. And then all the insides multiply together. What's 2 times 12 times 3? 72. Nice. All right, 72. Okay, we have to simplify, always. We always have to simplify. So 72, we could look for a perfect square number that goes into 72, or we could just break it down what we just did, right? This is 2 times 12 times 3, right? However you want to do it. So 2's already here. 12 would be 4 times 3. I'm going to go all the way down, you guys, to prime numbers. I'm going to factor it all the way down. So just to show you, if you can't always find that perfect square number. So which numbers have dates? Okay, we have a set of 2's and a set of 3's. That really means I'm taking the square root of 4, and I'm taking the square root of 9. Okay, what's the square root of 4? 2. What's the square root of 9? 3. So each of the dates leave as 1. In other words, I really probably had 36 in there, right? So we could have said that was 36 times 2, taking the square root of 36, which is 6. All right, so what's 24 times 6? What did you say? 48 times 3. That'd be 48. 144. Okay, and then the 2 that doesn't have a date stays inside. Make sense, you guys? Okay, and then a review of parallel lines. This is very similar to when we had the slope of a line, and they gave us another point, and we find the new equation of the line, okay? So it says, find an equation of the line that is parallel to the line 3y minus x equals 5. So write that equation of the line down and find a parallel line, or something about parallel lines, okay? And then we want it to be parallel, but pass through the point 3, 3. Okay, so if you just look at parallel lines, so just imagine parallel lines, do they have the same slope or the same y-intercept if these were graphed on an xy axis? That was really good. Ethan? Yep. Okay, these always have the same slope. If it's parallel, same slope. But different y-intercept, right? So this is the equation of the first line. We have 3y minus x equals 5. We want to keep the same slope from that line. So the first thing we need to do is find the slope, and we find the slope by solving for y. So I'm going to go ahead and move the x to the other side. And when it moves over to the other side, it goes positive. Okay, then I'm going to divide each piece by 3. What number's in front of x there that we don't see? Right, so this is really a 1/3 x plus 5/3. So now I want a line parallel to that line that goes through the point 3, 3. So if it's parallel, it has the same slope. So we keep the number in front of x. We don't care about the 5/3 because we're going to find a new y-intercept because it's a different line. It has the same slope, but a different y-intercept. Okay, so now I'm going to plug in 3, 3. They gave us that coordinate point, and it said I want a new line that goes through the point 3, 3. So 3 gets plugged in for y, and 3 gets plugged in for x. Okay, these multiply together, so these cancel here. So I have 3 equals 1 plus b. Subtract 1 from both sides. Now, some of you guys are leaving your answers like this when they're giving you the slope and you're plugging a point in. Is that the answer? No, we want the equation of the line, which means I keep the same slope, 1/3, and I plug in my new y-intercept